Hey, math class. Okay, I have made this video 2 other times, and I don't know where it has gone. So hopefully 3rd time is the charm, and that this will actually work this time. I think I'm on the volume. So hopefully this will work and I'll be able to find it. I have a timer set. I think that part of the problem is I'm trying to make too big of a video. So we're going to try it in smaller chunks and see how it goes, and then I'll put them back together later on. So if you hear a timer in the background, that's my cell phone timing and saying it's time to stop. Hey, so this part is talking about the solving of systems of equations. Which is kind of what we're going to be focusing on in sections 8, 4, 5, and 6. So I'm going to add this, our 6th thing. It's going to be pages 10 and 11 for me. I'm going to go back and add to my goal on page 8. I'm going to talk about systems of equations. And I have this pretty cool thing, which I have posted underneath this video in the assignment. If you don't have access to a printer, that's okay. You can still sort of write all of this in your book, but if you have access to a printer, this is a pretty cool, pretty slick little thing, mainly because it talks about all of the steps to the 3 ways that you're going to solve systems of equations. To get them to fit into my book, I'm just going to kind of cut them like this. And then I'm going to put them in my book and turn it sideways like this. But mainly the goal for all solving of systems of equations, we are looking for one point. One coordinate where the 2 lines intersect. So like we were just talking about. So that's our goal for everything. So I kind of put that over here. We are looking for one x value and one y value that then will become a coordinate on a coordinate plane. So let me grab a glue stick here. I'm going to sort of glue this in here. And so the first way that WAMAP is going to show you how to solve a system of equations is by graphing the 2 lines, which we kind of have done in the first part of our unit 2, which is the curriculum's unit 8. Okay, so, but let's kind of just go through all of the steps here so that we can see all of the pieces. So step 1, all problems need to be in a certain form, which is y equals mx plus b, which if you remember, that is our slope-intercept form. That tells us what the slope is. It tells us where it crosses the y-axis. And so this is the format that we need these to be in order to be able to graph them. So, this one right here are my 2 example formulas. Just kidding, not formulas, equations. And this one you see is already in y equals mx plus b format, but this one is not. So if the problem is not in that format, I need to solve for y first. So I'm just going to come over here in this little area right here. That's exactly what it's there for. I want to get everything away from this y so that he's the only thing on this side of the equal sign, and I've got all of my x's and everything else on the other side. And so if we look at it, means that I have to move this negative 4x. Since I'm moving him across the equal sign, I'm going to do the opposite, right? So this is negative 4x. It means I'm going to add it. I'm going to plus 4x, and that gets rid of it over here. So then all that I have left on this side is the y. And then because I want it to be an mx plus b format, I'm going to put 4x first, and then I'm going to say minus 3, because that's going to show me what my slope is and what my y-intercept is. And if I have it the other way, I might get confused. And I just like to not confuse myself as much as possible. So now I have my this I'm just going to pull right over. Now I have my two equations written in y equals mx plus b format. And so now I'm going to graph my equations onto a coordinate grid. So let me start with this one first. I have a positive slope of 4 over 1. So that means that my line is going to be going uphill from left to right. And I know that it's going to cross the y-axis at -3. So I'm going to go down. Oh, hi, buddy. Hi, sweet boy. Yeah, we're on a time crunch. Come on, buddy. Get down. Are you going to help us graph? Huh? Okay. He's going to headbutt the pencil. Go away. Sammy, go away. Come on. Okay. So I'm going to go down here. Oops, I made a little line there. To 1, 2, 3, down to -3 right here. So that's where I know that this first equation is going to cross to the y-axis. Remember, because this is my y and this is my x, and so it's going to cross at -3. And then my slope is 4 over 1. So that means I go up 4 over 1. So I'm going to go up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. So I'm going uphill from left to right again because I know that it's a positive slope. And I'm just going to kind of go zoop like that. There is my first equation graphed. Now let's go on to the second one. So this one has, that's my timer. I'm going to kind of keep going here. We'll see if this will work. Okay. I have a negative slope on this one, -2. So I know that it's going to be going downhill from left to right. And I know that I cross at 1, 2, 3, at +3. And then I know that I'm going to go down 2 over 1 because this is -2 over 1. I'm going to go down 2 over 1, down 2 over 1. And so then here is my line for that second equation. And I can already see that I have crossed, these lines have crossed at a point. And that point is, so I'm going to locate the intersection. That's my next step, which for these two lines is right there. 1 over, 1 up. So that is the coordinate 1, 1. And so then my last step is to check the solution with your original equations. So I'm just going to take that 4x, or -4x plus y equals -3 from way over here. And if I plug in 1 for both of these guys, for the x and the y, right, because x equals 1 and y equals 1, do I end up with the same answer on both sides? So let's see here. So -4 times 1 is -4, plus a +1 is -3. So I end up with -3 on both sides of the equal sign, so I know that it checks. How about over here? Y equals -2x plus 3. Again, if I put in 1 for each of those, do I end up with the same thing on both sides? -2 times 1 is -2, plus 3, that's going to be 1, +1, I end up with +1 on both sides, so that checks as well. So this is the first way to solve systems of equations, is by graphing. Okay, I think the smaller chunk worked. Ha! So we're just going to keep doing that. Okay, so I have my timer set again. Let's talk about the second way that WAMAP is going to walk you through solving systems of equations. And again, this is a really quick overview. You'll get to really dig into this in WAMAP in those sections 8.4, 8.5, and 8.6. but I just thought to have them all in one place to kind of reference would be a good thing. Okay, so the second way that you're going to solve a system of equations, we already did graphing. That was the first way. The second way is by substitution. And this is kind of my favorite way. I don't know why. It's the way that makes the most sense for my head. Hopefully you're finding that there's a lot of different ways to do the math, and it's just a matter of figuring out what makes sense for you, and then kind of doing it that way all the time. WAMAP's going to walk you through all three of these ways, but at the end, you kind of get to pick which way you like best. But anyway, okay, substitution. So the first step that we're going to do is to solve one of the equations, preferably the easier one, for either x or y. So up here we made it into y equals mx plus b. We were kind of solving for y because this is what y equals. And then down here it says if one of them's not done already. So if you look at our examples right here, look at this, y equals 4x. I already have one of them that's set to say y equals something already. And then see how this one is kind of a more complex equation? I'm going to leave that one as it is. And so then for step 2, substitute. I always spell that word wrong. I feel like it always has too many T's, but that is right. Substitute, this is a U. How did that get so messed up? Substitute. I'm going to substitute the equation set to x or y into the other equation, and then I'm going to solve for the variable. So that's a lot of words. Let's sort of break down what this means. It means I'm going to take this y equals 4x and I'm going to plug it into 2x plus 3y equals 28 for y. So let me show you what I mean by that. 2x plus 3 times 4x equals 28. So I've taken what I know from one equation, that y equals 4x, and I've plugged that in to the y variable in the other equation. So then I only have x's, right? I've got an x there, I've got an x there. I can see if I can combine them and solve the equation for x. So let me do that. What's 3 times 4? Well, that's going to be 12. 12x plus 2x equals 28. 2x plus 12, or 2 plus 12 is 14x. My cat is playing with something in the background. Hopefully that's not too noisy. Okay, 14x, to get that x by itself, I'm going to divide by 14. Divide by 14. That gets rid of that. X is going to equal 28 divided by 14 is actually 2. So what this is telling me, like up here, right? I was looking for a coordinate. This is telling me that the x coordinate of my overall coordinate that I'm looking for is going to be 2. So now I need to find the y. So I'm going to substitute my answer for x into the equation that you changed, or hello buddy, come on, see me. I'm going to substitute my answer, so the x that come on bud. Oh, cat, come on, buddy, get down. Thank you. Okay. I'm going to substitute the answer into the equation that I changed or that I used first, and I'm going to solve for the other variable. So just like I plugged in 4x because that was what y was, now I have an actual answer for x. So I'm going to plug that into one of my equations. I'm going to pick the easiest one. Y equals 4x. And now I'm going to plug 2 in because I know that x equals 2. So y is going to equal whatever 4 times 2 is, which is 8. So that means that my answer for this one is going to be 2, 8. Up here I had 1, 1. That was my answer. Here I've got 2, 8. If I were to graph these two equations, they would intersect at this point. This is where they cross. And again, I'm going to plug them in and check my answers. So I'm going to put 2 in for X and 8 in for Y. 4 times 2 is 8. So this one checks out. And then the other one is 2X plus 3Y equals 28. So I'm going to put 2 in for X, and I'm going to put 8 in for Y. And I'm going to see if I get the same answer on both sides. 2 times 2 is 4. 3 times 8 is 24. 24 plus 4 is 28. It checks. And so the reason that I do this checking of the answers is to prove to myself that yes, this point that I found is on both of these lines. If I come out with the same answer on both sides, I know that it's on both lines. So that's the second way of solving systems of equations. Okay, so our third way of finding our one coordinate answers, can you guys see that okay, is, let me get a little closer here. So the third way to solve systems of equations to find that one coordinate answer is the elimination way. So I'm just going to glue this into my book so that I have the steps right there for me. And again, you're going to dig into this more in WAMAP, but this is just sort of a general overview. If you don't like the way that they explain it in WAMAP, then you have, this is kind of a backup, hopefully. Okay, so step 1 is that I'm going to rewrite the equations if needed so that when added together, one of the variables will be eliminated and the remaining variable can be solved. So I'm going to get rid of one and solve for the other. I'm going to get rid of either X or Y and then solve for whatever is left. So they give me 2 examples here. We've got 1 and 2 different equations. The first one is 2x plus 4y equals 10. The second one is negative 4x plus 2y equals negative 30. And the way that they're coaching me to do this is to rewrite the first equation. I want to multiply this whole equation by 2 because then I'm going to have I'm going to have x's that cancel each other out. So let's do this. 2x plus 4y equals 10. I'm going to times that whole thing by 2. So then I end up with 4x plus 8y equals 20. So I have this new first equation. Then my second step is to add the equations together, the new first equation and the original second equation. So I'm going to take that 4x plus 8y equals 20, and I'm going to add to it this one, this negative 4x plus 2y equals negative 30. And I'm going to combine those. And if you notice, positive 4x and negative 4x, those cancel each other out. And so all that I'm left with is 8 plus 2, which is 10. 10y equals 20 plus a negative 30 is going to be a negative 10. Divide by 10 to get that y on its own. Negative 10 divided by positive 10 is negative 1. So that means in my answer, like the coordinate that I'm looking for, I know that my y is going to be negative 1. I'm still looking for the x though. So that's my step 3. I'm going to substitute that y equals -1 into our original equation over here. And actually, I could use either one of these original equations, because if this is the point where these two lines cross, they would have the same x and y. So it shouldn't matter. I would get the same answer whether I put -1 into this one or that one. But they are coaching me to put it in to this one. So that means I'm going to plug -1 in where there's a y, and I'm going to solve for x. So 2x plus 4 times a -1 is -4. So I'm just going to change this to a -4 equals 10. I need to get this x by itself, so I'm going to move this over here, and I'm crossing the equal sign. I'm crossing the equal sign, so I got to do the opposite. What's left over here? So 10 plus 4 is 14. 2x equals 14. I want to get that x by itself, so I'm going to divide by 2. X equals 7. So I know that then the coordinate that I'm looking for to solve this particular system. Oh, hi again, buddy. You're 3 for 3 then. Come on. Out of the video. Okay. So the point that's the spot where these cross that solves this system of equations is going to be 7, -1. And again, I'm going to check my answer. I'm going to substitute x and y values into the original equations. And again, the left and right sides of each equation should be equal. And I'm not going to walk through that because we've done it a couple of times. And oh, now here's Benny. The whole cat nation is out today. Come on, your tail's in our video. Okay, so this is the 3 different ways that you'll be working with in WAMAP to solve systems of equations and look for that one point. Look for your answer, which is going to be a coordinate, an x comma y. Hi, buddy. You're in the video. And again, my favorite is that substitution method. I don't really like the elimination method. But you might find that this is the way that makes the most sense for your head. So go ahead, just solve everything kind of the way that makes the most sense. It's important to know the other two and to know how to work with them. But, we're all going to have a favorite, and WAMAP's going to make you practice all 3. So, anyway, hey, so far so good with the videos. They have all uploaded fine, and I haven't lost any of them. I'm very excited. Hopefully the 3rd time will be the charm, and I will be able to post this for you. Our assignment this week is 8, 4, 5, and 6. So you're also a part of your assignment is to kind of check in with me sometime during one of my office hours so I can make sure that you're doing okay. I just want to see your face or hear your voice and hear how it's going. So, hopefully we'll have time to connect sometime this week. If you've got any questions at all, please do not hesitate to text me, call me, shoot me an email, so that I can help with this stuff. Because I know that this is probably new information for some of you, so I am here to help.